we going to do tonight?
Only thing we're doing in class is imaginary numbers.
Okay. So you're adding, subtracting, multiplying, and dividing?
Haven't divided them yet.
Okay. That's the only one that's hard. In other words, if I have this problem here, and I say add this, what's the answer?
6 minus I.
5 minus I. We're adding them.
Oh, that's right.
Okay. If I say subtract them, what is the answer?
1 plus 9I.
Good. If I say multiply them, what is the answer?
6 minus 15I plus 8I minus 20, or plus 20.
Good. So that becomes 26 minus 7I. You always kind of want to put your answer in A plus BI format.
Okay.
Even if it's a fraction. Suppose you solve a quadratic and you get 2 plus or minus 2 root 3 all divided by 2. Well, go ahead and divide that out. In other words, turn that answer into 1 plus or minus root 3. Okay, so the only thing we didn't do is divide. Let's talk about dividing, because it isn't really division. Addition is addition, multiplication is multiplication, but division is really more like rationalizing a denominator. If I gave you an answer like this, what would you do to make that a proper mathematical expression?
I have no idea.
Multiply by the denominator, over the denominator. In other words, we can multiply a fraction by 1 without changing its value. In this case, my 1 is root 5 over root 5. And what that gives me is 2 root 5 in the top and 5 in the bottom. So I have gotten rid of my irrational denominator by rationalizing it. Same number, these two are the same numbers. It's just this one has the irrational number in the numerator, which is where it's supposed to be. Same principle for imaginary numbers. What we want to do is realify this denominator. Right now we have an imaginary denominator. You don't want that any more than you want irrational numbers as denominators. So we're not really going to do division. We're going to multiply this by 1. And my 1 is going to have the conjugate in the denominator. And of course the same thing in the numerator, because I can only multiply by 1, and that's equal to 1. Now, by multiplying the denominators by the conjugate, I eliminate I. Notice that if you multiply 2 minus 5i times 2 plus 5i, you get 4 plus 10i minus 10i minus 25i squared. Okay, this numerator becomes 6, let's see, we have 8 and 5i, excuse me, 8i and 15i, so that's 23i, plus 9i, plus 20i squared. So now notice the denominator turns into a real number. 4 minus 25i squared is 29. The numerator, well, this turns into a number. That's minus 20. So now we have minus 14 plus 23i. There's my answer. And I've accomplished what I'm trying to do, which is to get rid of my imaginary number in the denominator. I don't care if I still have an imaginary number in the numerator. That's okay. You just don't want imaginary numbers in your denominator. So this expression conjugate. Tell me what the conjugate of 7 plus I is.
7 minus I?
Uh-huh. So that's all there is to it. That's the 4 operations you can do with I. Now, there are a few other things you need to know about I. Not much, though. What's I squared equal?
I squared equals 1? No.
Negative 1.
Negative 1.
In other words, I times I, square root of negative 1 times square root of negative 1 is whatever is under the radical of negative 1. It's I cubed.
I cubed I?
Well, it's I times I squared, right?
Negative I.
And finally, what's I to the 4th?
1.
And then they repeat. In other words, I to the 5th is equal to I to the 6th is equal to I squared, or negative 1. I to the 7th equals minus I, and I to the 8th equals 1. So, what is I to the 16th?
1.
What is I to the 100th?
I.
1.
Oh.
And lastly, what is I to the 501st power?
I don't know.
Well, we divide this by 4. Up here we divided it by 4. There was no remainder, so it's equal to 1. Right here we divided it by 4. There was no remainder, so that's equal to 1. Here we divide by 4 and there's a remainder of 1. Go to your first row. That's equal to I. I to the 502 would be equal to I squared.
Okay.
Okay? So that's how you handle I's to big numbers. And you probably, if you learn this, you will have a question like that. What is I to some giant exponent? Just divide it by 4, take your remainder, and go to whatever row your remainder gives you. So what would I to the 27th be?
You divide by 4. The remainder of 3, so it'd be negative I.
Yep.
Okay.
That's pretty much all you need to know about I. Is adding, subtracting, multiplying, dividing, and figuring out I's to large exponents. Do you have any specific problems you want to do?
What?
How about solving a quadratic? Let's solve a quadratic where the answer is I. Let me give you a problem. First of all, can you factor this?
No?
Did you say no?
Yeah.
Okay. So how do we have to solve it? If I'm going to say this is equal to 0 and I want to find the values of x that make this equal to 0, I'm going to use what? If something isn't factorable, what do you have to use? Quadratic formula.
Okay.
Remember what it is?
Then x equals negative b over 2a.
Negative b over 2a is the vertex of a quadratic,
Okay.
but the solution, and that's half of it, but there's one more thing here.
Plus or
Now,
minus.
yeah. Now, let me help you memorize this, because you need to memorize this. The first half of it is the same as the formula for the vertex of the quadratic. The second half, or the other important part, is this b squared minus 4ac. That actually has its own name. It's called the discriminant. And the reason it has its own name is because we frequently want to examine this all by itself to determine whether it's positive or negative. Notice that if b squared minus 4ac is a positive number, then this is going to have two real solutions. If it's a negative number, this is going to have two imaginary solutions. And if it's equal to 0, it's going to have exactly one real solution. So a lot of times, if I'm going to solve something and I only care about real solutions, I might do this real quick to determine, well, that's a negative number, so I don't have any real solutions.
Okay.
Okay? So let's go ahead and solve this. What's A, B, and C?
A would be 1. B negative 1. And C would 10.
Okay, so now let's plug in. What do we got? We got x equals, what's minus b?
1.
Plus or minus b squared would be 1 minus 4 times 1 times 10, all divided by 2. So there's our two solutions, but let's simplify them. First of all, what?
Be minus 40.
Well, it'd actually be minus 39, I think.
Oh.
See why?
Yeah.
It's 1 minus 40. Okay, now we're still not quite done. In other words, our solution is in terms of a radical of a negative number, so we need to turn that into I. So how do I convert minus the square root of minus 39 into I? Show you an easy way to do it.
Once you do like your factor tree.
Well, no, it's not that hard either. Let's start by always breaking it up into a square root of minus 1 times the square root of the number. In other words, I can do that because the square root of a times b is equal to the square root of a times the square root of b. Okay? So I can always take my square root of the negative number and turn it into the square root of minus 1 times the square root of the positive number. Now,
Okay.
What is this? That's equal to, that's I, and this is square root of 39. Which doesn't simplify. That's square root of 13 times square root of 3, both of which are prime numbers. So that doesn't simplify any. So my answer to this equation is 1 plus or minus square root of 39i all over 2. And then if I really want to put it in the form of a plus bi, then I have to separate this into two partial fractions. First one is 1/2 plus or minus root 39 over 2i. So my solutions are 1/2 plus root 39 over 2i and 1/2 minus root 39 over 2i. In other words, I have two solutions, but they're both complex. They both involve imaginary numbers, which means there are no real solutions to this equation. There are no positive or negative real values for x that make this true. The only values that make this true are these two complex solutions right here.
Okay.
Okay, so only real trick is turning square roots of radicals into simplifying. So let's do a few of those. How about this one? That's a negative.
Okay.
So first of all, what would it be? Let's just split out the I from it.
Square root of -1 times square root of 200.
Okay, which is I times square root of 200. Now let's simplify that. Now this is where you want to use your factor tree kind of. Although I don't know that you have to go to that much trouble to use a factor tree. I guess it makes it fairly easy if we use a factor tree. Which one of those is a perfect square?
2.
No.
Or 10.
10. So square root of 200 becomes what? Well, we can write it as, we can write it like this, right?
Okay.
And then this becomes 10. So I might not stick the I in front like that. I would probably write it like this. Be a little careful when you're writing these. It's really easy to have that I slip under the radical sign, and that's a whole different meaning. So you might even want to be reluctant to put the I after the radical. You might want to put it up front like 10I square root of 2. Little less likelihood of somebody misreading it. So what's the square root of -16?
Square root of -1, square root of 16 equals I square root of 16 be 4I.
Yep. That's it. Well, I can't think of any more problems. Do you have any on your end that we can do that are kind of like this? I mean, is it fully imaginary numbers? That's all you were dealing with in class today?
Yeah, that's all we're doing.
Well, it's hard to imagine that you dealt with anything that I didn't cover tonight. Because there's only so many things you can do to imaginary numbers. You can add them, subtract them, multiply them, divide them, and exponentiate them. Not much else. I don't know. Do you have a problem that's different? Or even the same?
But
Even similar? We got 10
I don't
minutes.
have any more of the dividing, because that's the only one I'm kind of Still
All right, let me make
confused.
some up for dividing. I'll make one up. So what do I have to do to make this a valid mathematical expression?
Once you have to multiply it top and bottom by 2 minus I.
By the conjugate.
Conjugate.
Notice that if I multiply it both by 2 minus I don't get rid of the I in the denominator. In other words, my goal is to get rid of this I. I can't stand it in the denominator. I don't mind having it in the numerator. There it is in the numerator. But in the denominator, think of this as the difference of squares factored. So I know that this is going to be 4 minus I squared after I multiply 2 minus I times its conjugate. Well, this becomes 6 plus 3I over, what is 4 minus I squared?
4 minus I squared, 5.
This answer isn't really a good final answer. We want it in A plus BI form. So what is the final answer? Separated into two fractions.
So you'd have 6/5.
Notice that this bottom answer is A plus BI format. This was not. This was an imaginary, a complex number divided by an integer. A plus BI format, this is the real part, this is the imaginary part. If I was plotting this, have you graphed?
No.
Well, when you graph imaginary numbers, the vertical axis is the imaginary axis, the horizontal axis is the real axis. Okay? So if I was graphing this number, I would go to 6/5 and I would go up to 3/5. And the coordinates on that would be 6/5, comma, 3/5 I. When you graph complex numbers, you only have you don't have three axes. You just have a real axis, the horizontal one, and the imaginary part's the vertical one. But to plot imaginary numbers, they have to be in this format. In other words, I couldn't plot that. 6 plus 3I over 5. I have to separate it into the two fractions, the real part and the imaginary part. What's this?
I do.
Now remember, my only goal is to get rid of the I in the denominator. What's the simplest way to do that?
Multiply by I?
Well, I can't multiply something arbitrarily by I, but I can multiply something arbitrarily by 1. I over I. So what does that give me? It gives me 4I on the top, I squared in the bottom, which is minus 1, minus 4I is my answer. Now, notice that I didn't multiply by the conjugate. I could have. What's the conjugate of I?
Negative I?
Yeah. The only reason I didn't have to multiply by the conjugate because it didn't have a real part to it. But I could have, if I had multiplied it by negative I, now the numerator is minus 4I and the denominator is plus 1. So I still get the same answer. It's just a little more straightforward to just multiply it by I over I. That clears the imaginary part from the denominator. That's our goal. The problem is if I put a real number in front of that, let's say 2 minus I, now I can't multiply by I over I. It won't get rid of the imaginary part in the denominator. The only way to get rid of the imaginary part in the denominator is to multiply by the conjugate. What's the conjugate of 2 minus I?
2 plus I.
And since I have to multiply it by 1, it's got to be 2 plus I over 2 plus I. And this times that will automatically get rid of the I from the denominator. Notice there's no middle term anymore.
Mm-hmm.
They both cancel when you FOIL this. So that other one I gave you was kind of a trick question, where I put just an I down there, because this is the only time you can actually get rid of the I without multiplying by the conjugate. You just need to multiply by I over I, and you'll get rid of it. It's the same exact concept as rationalizing the denominator. How do I rationalize that fraction?
You multiply it? No.
By what? Yes, no, you're right.
Oh.
In other words, my goal is to get rid of the radical sign in the denominator.
So by 1.
No, by square root of 3. Well, yes, you're right. I'm multiplying it by 1. That's the only thing I'm ever allowed to do to a fraction, is multiply it by 1. But notice that when I multiply it by root 3 over root 3, I get root 3 over 3. That's the way to give that answer, because this has a rational denominator, and that's the rule that all mathematicians have lived with, is that you don't put irrational numbers as denominators, and you don't put imaginary numbers or complex numbers as denominators.
Okay.
Remember, equations, you can do anything you want to both sides as long as it's the same. If I want to divide both sides by 117, I can. If I want to square both sides, I can. If I want to take the log of both sides, I can. If I want to take the integral of both sides, I can. That's different than working with a fraction. If I have a fraction, I can only multiply or divide this thing by 1. Well, I'm going to divide the top by 2 and the bottom by 2, which is the same as dividing it by 1, and that reduces it to 1/2. So when you're manipulating any kind of a fraction, you're stuck with only being able to multiply it by 1. I can't do anything I want. I can't square both top and bottom. Notice if I square both top and bottom, I get this, which is not the same number as that. So the only thing you can do to a fraction to change it is multiply it by 1, and you can make the 1 anything you want. All right. If you don't have any further questions, let's end it there. We're doing half-hour sessions, right?
Yeah.
Both tonight and tomorrow night and Wednesday night.
Okay.
Regularly, we're just going to do half-hour sessions. Is that correct? Because last week I think we did an hour on Tuesday. And if you ever need to do an hour, that's fine. Just let me know. You know, if you have a test coming up on Wednesday or something and you want to make the Tuesday session an hour session, easily done.
I know we don't have a test this week, so half hour is fine.
I don't usually have anything after you. In other words, it's not normal that I would have an 8:30 session, so If you just
Okay.
decide you want to expand it on the spur of the moment, that's almost always going to work. The only time that's different is tonight. I happen to have an appointment right now that I got to go to.
Okay.
I will text you the meeting ID tomorrow at 8 o'clock.
Okay.
All right? All right, Silas. Talk to you tomorrow.
Okay.